What's up, stats class? For my project, I chose the data of speed and heights of roller coasters, as you can see right here. Here's a summary sheet of 30 different roller coasters with speeds. And we have a minimum of 40, maximum of 93, and 8 classes with a width of 7. Down here you can find the mean, mode, and median. The mean equals 64.6, and the mode and median are 65. If you look to the right for the histogram, you can see that it's not like exactly bell-shaped, but it is slightly right skewed. The histogram is also a single mode since it only has one peak, and due to the histogram being skewed to the right, the best measure of center is the median, because any outliers from the right tail won't have any great effect on it. And then the measurement closest to the mean would have to be 65, which has a standardized data of 0.031, as you can see right here. In the sample of the 30 roller coasters, only one roller coaster is 2 standard deviations beyond the mean, which is 93. So you can say 3% of my sample data is 2 standard deviations beyond the mean. And in chapter 3, it states that 75% of your values should fall within 2 standard deviations. So on my data, 97% falls within 2 standard deviations, which is more than the 75% in chapter 3. For my confidence interval, I used the roller coaster speed data. And the question was, using your sample to estimate the average maximum speed for 61 roller coasters with a 99% confidence interval, I was able to see that the lower, which was 58.03, and the upper 71.17. So in the end, I was able to say that I am 99% confident that the mean of the maximum speed of roller coasters will be between 58.03 and 71.17. When doing my hypothesis test, I was supposed to test the claim that a majority greater than 50% of these roller coasters have a maximum height of more than 100 feet. I use a significance level of 0.05, and my null hypothesis was 50% or fewer coasters have a height of above 100 feet, and the alternative hypothesis is more than 50% of roller coasters have a height above 100 feet. Or more, you can say that there is enough evidence at a significance level of 0.05 to help support the claim that a majority of the roller coasters have a maximum height of more than 100 feet. And for my correlation, I'm going to pull that up. For my correlation, I picked the height of roller coasters to be the x value, and the speed of my roller coasters be my y value. And my reasoning for that is because height can be the cause of whether a ride to speed up or slow down. And looking at the scatter plot right here, down here, you can see that there is a significant linear correlation that exists between the maximum heights and speeds. And for my other questions, I was asked to estimate the maximum height if the maximum speed of a roller coaster was 70 miles per hour, and to estimate the maximum speed of a roller coaster with a maximum height of 325 feet. And which one would I tend to believe more? For the ride of maximum speed of 70 miles per hour, the maximum height would be 176 feet. And for the roller coaster with a height of 325 feet, it would have a speed of around 99 miles per hour. And out of these two rides, I would believe the roller coaster with the speed of 70 miles per hour because it falls between the range, while the ride with a height of 325 falls outside the range. And in a correlation problem, you would want to make a prediction between the ranges because going outside of the ranges can lead to inaccurate predictions. And that's all I have for you today. Thanks for watching.